Welcome students. So last class we have seen the properties of the rank of a matrix, and in this lecture I would like to cover how to compute the rank of a given matrix capital A by reducing it to echelon form or echelon form, what you can see. Echelon form means it is a pattern followed by the army planes when they do some feats in sky. They form a triangular pattern. Based on that view, that pattern, we are going to reduce the given matrix. Whether it is square matrix or a rectangular matrix, we are going to get that pattern. Simply we can say reducing or transforming the given matrix, whether it is a square matrix or a rectangular matrix, into upper triangular form. Upper triangular form or upper triangular matrix. This is already covered. Watch the videos what I am covering in Matrices playlist starting from 1, so that you get all the notations and terminology what I am going to use in coming videos without any confusion. So let us start how to compute the rank of a given matrix capital A by reducing it to echelon form or echelon form. Let us consider a square matrix of order 2 by 2. First asserting a 2 by 2 matrix. It is a square matrix of size 2 by 2. 2 rows, 2 columns. So this is your row 1, row 2. To reduce capital A to echelon form. Apply only EROs. EROs means elementary row operations. So this is a condition to be followed strictly. To reduce the given matrix capital A to echelon form, apply only EROs, elementary row operations. How to apply those elementary row operations? I will give the pattern so that you can able to work out for any square matrix or any rectangular matrix. Same logic. First, you mark the diagonal, and you see what are the elements below the diagonal. Here only one element is there. You highlight that. There you need to get a 0. Here you need to get a 0. So this principle you apply. CR, right, means changing row. For EROs. For ERO, changing CR stands for changing row. This arrow symbol stands for reduces to. Again, CR means changing row. Give some gap. UR. This is called using row. Changing row reduces to changing row. Some gap I maintained there, using row. Here you need to take plus sign or minus sign before you write that sign between these CR and UR. You check the sign before the first element and the first element here. Positive, positive. Same signs are there. You take minus. If opposite signs are there, you take plus. Be careful. Changing row, reduce to changing row, using row here. Leave some gap to fill the sign over here. Check the sign of the first element and this element. Here we are going to get 0. So see, if the signs are same, then you take minus. If signs are opposite, you take plus. Then the first number, first non-zero number should be multiplied to CR. And the bottom one, you follow this pattern, top to down. First here, then the bottom number 9 here. 9 here. So keeping in view, we can write the operation like this. Apply. Changing row is R2. So R2 reduces to write R2. Why? Because CR. Leave some gap. Using row is when you want to make zeros in first column, make use of R1. If you want to make zeros in second column, make use of R2. If you want to make zeros in third column, make use of R3. So changing row will repeat twice. The using row will be the R1. Only R1. Now come back here. What sign you need to fill here? Plus, same signs are there. You have to take minus sign. Already give the numbers here. 1 for first R2 and 9 for R1. So to get the changing matrix based on this, so to avoid confusion, 1 R1, R2 changes to 1 R1 minus 9, 1 R2 minus 9 R1. So here only this row is going to change. So one operation only, 1 into, what is R2? 9 minus 9 into, what is R1? This becomes 0. Next here, this element, 1 into 3 minus 9 into 4. First, second. So it is equal to 3 minus 36. It is minus 33. Minus 33. Now make use of those elements. You get the new matrix. When you are going to write down the new matrix, we use the symbol. A changes to. Here row 1 will be same. And row 2, 0 minus 33. Again use the diagonal pattern. And you see no elements are there below the diagonal. So this is the matrix called Echelon Form. Echelon Form of A or Echelon Form of A. It is the ending process of that row operation, elementary row operation. How to give the rank expression now? Rank of A. It is called rank of A. Rank of A is given by number of non-zero rows in echelon form of A. So 1, 2. Non-zero row means every element, at least one of the elements of each row must be non-zero. If every element is zero, it is called a zero row. So here it is one non-zero row, second non-zero row. So it is 2. The rank is 2. Rank is 2. So this idea very simple for a 2 by 2 square matrix. In next video, I will be explaining by taking a rectangle matrix so that many EROs we are going to get. Same logic we are going to apply without any confusion. Ultimately, there is no read track method to check your answer in rank. So my suggestion is that you be careful in the beginning itself. When you apply ERO, elementary row operation, be cautious. Because even one simple error, if you commit in ERO, the rank may not be correct. Even if you get correct, they may check that operations how you got. If the rank goes wrong, everything goes wrong. So take extreme care while computing EROs. That's why I gave you separately after this application, the previous contest, how you are going to get the new elements. Based on the same thing, below that you write down how many changes you are going to get. Here one change, here one change. So 2 things we are going to do. 2 times I do the same operation. In place of R2, you copy the elements of R2. In place of R1, copy the elements of R1. So use simple arithmetic, you are going to get the correct results. Then don't forget to write down this statement, number of non-zero rows in echelon form of A. Do share, subscribe and share our video to your friends. All the best.